Hello everybody, this is Dr. Gopinath Haldar from Department of Chemical Engineering, National Institute of Technology, Durgapur. I welcome you all on SWAM online course on heat transfer under the discipline of chemical engineering. And today I would like to emphasize on evaporation of heat transfer. So, let us have a look on the module outlines. So, what basically I am planning to cover in this particular module, the essence of evaporation and classification, schematic of various common evaporators what we generally use in our different industries and chemical process industries, and the influence of liquid properties on evaporators. What are the different properties that we should consider for the evaporation operation to occur very efficiently, and what are the different properties of liquid what generally influences the evaporation process or operations. Method of feeding of evaporators where the different kinds of feeding that we generally consider in evaporation operations. Performance evaluating factor of evaporators, what are the different factors that can be taken into consideration for evaluating the performance of an evaporator. Boiling point, elevation and overall heat transfer coefficient, these are very important point, these are very important parameters that we need to consider for the performance of an evaporator, where this boiling point, elevation and overall heat transfer coefficients are that we require to calculate in order to design the evaporator. Design methodology of an evaporator. So, as an engineer, what are the different methods, what are the different steps to be carried out for the design and development of an evaporator for its specific application in the commercial exploitation in the different industries. So, that we need to take care of. So, this design methodology, so that we will be also discussing. Illustration of problem solving techniques. So, the different methods, so that we will be discussing, but based on that method which will be the specific method and which will be the technique that we can adopt for the estimation of different parameters associated with these evaporation operations. Application area and selection criteria of evaporators. So, what is the application area of this evaporator, where it can be recommended, where it can be applied for its specific operations, and what are the different selection criteria. I mean, what are the different criteria that we must consider for the recommendation of an evaporator as an engineer. So, these criteria, these are very specific and these are very important to be taken care of for the selection of a evaporator. Now, let us first define what is evaporation. So, first of all we need to know what is evaporation. Evaporation, this is an operation, it is a very simple operation which converts a liquid into a vapor. That means, this process is nothing but a evaporation process where this liquid is vaporized and finally, we are getting the concentrated liquor or concentrated solution of higher boiling point. Now, these functions of an evaporator, what are the different functions? Basically, what does an evaporator function? What does an evaporator do basically in industries? So, basically if we can consider this heat, what is the heat? I mean, what are the different kinds of heat that are required for this evaporation process to take place? So, it may be definitely consisting of two different kinds of heat. One is sensible heat and latent heats of vaporization. You know, this sensible heat, it basically serves the function to reach its boiling point. I mean, the boiling point of the liquid is supposed to be evaporated in an evaporator, and this latent heat, this is the latent heat of vaporization that is required for the vaporization of the liquid, I mean the dilute liquid or dilute liquor, which will be converted into concentrated liquor or thick liquor. And the vapor removal, this is very important, because this vapor pressure of this liquid that is to be taken care of continuously when this evaporation process takes place and producing a concentrated liquor. The concentrated liquor, that is our main product, that is the desired product. So, that will be produced by this evaporator. So, these are the basic functions that can be considered by an evaporator. So, now the schematic of evaporation. So, this is a very simple schematic of this evaporation to better understand the evaporation operation. Here just let us have a look onto this figure, where this cold feed, that means this feed or the dilute liquor which is supposed to be converted into concentrated liquor or thick liquor. So, this cold feed that has been introduced at the intermediate of this evaporation chamber, and the steam that is supplied to the evaporation chest for heating, and this is basically the heat source, and this steam that is supplied to the evaporation chest and the condensate that will be getting basically as output of this. And the superheated vapor, as the process proceeds, what will happen, basically this concentration of the liquor that will go on increasing, and the solvent will be vaporized, and the superheated vapor, as the process goes on, the superheated vapor will start producing, and gradually it will be released from this top of this evaporator, and the concentrated liquor. So, this is the aim of this evaporation process, where this concentrated liquor is the desired product, and that will be getting, and here that is mentioned that this is getting basically from the bottom of this evaporator. Now, the common solutes and common solvents. So, so this sodium chloride, caustic soda, caustic potash, phosphoric acid, sodium sulphate, urea, these are the common solutes that you can use, and the common solvent is water. This is generally used in most of the cases where this water is used as the common solvent, and common solutes, these are the common solutes. So, this is just an idea about the evaporation process, what is the role of these solutes and solvents, and where the steam, how it is supplied, why we are getting this condensate, and the product basically superheated vapor that we will be getting is one of the component of the exit products, and the concentrated liquor is the main desired products that we will be getting, and feed is that is to be introduced at the, it might be from the bottom, it might be from the intermediate plate or intermediate section of a evaporation chest. This is the difference between the evaporation and boiling. Sometimes one gets confused about the difference between this evaporation and boiling. What is evaporation and what is boiling? What is the basic difference between these two different processes? Now, this evaporation and boiling. So, where this evaporation that we know, this is very well known to everybody, that this evaporation that occurs at any temperature, at all temperatures, when this partial vapor pressure is less than its equilibrium vapor pressure, and boiling, this occurs at boiling point when vapor pressure is equals to atmospheric pressure. So, this is a very simple phenomenon, and this occurs at surface of liquid, this evaporation process, this is nothing but the surface phenomenon, and boiling, it occurs throughout the liquid, that means this is a bulk phenomenon. So, this difference between this evaporation and boiling, it can be well resembled with the difference between this absorption and adsorption in chemical engineering, because this absorption is nothing but a bulk phenomena, and this chemical adsorption is a surface phenomenon. So, here simply for evaporation and boiling, so we can differentiate it, evaporation is a surface phenomenon and boiling is a bulk phenomenon. And here in case of evaporation, heat is generally added from the top, because this is a surface phenomena. So, this reaction or this evaporation that will be carried out basically at the surface of this liquid, and heat is generally added from the bottom in case of boiling. Now, this evaporation, this is a very slow process, and boiling, this is a fast process, and this evaporation does not involve formation of bubbles, and the boiling, it involves formation of bubbles. So, this is the difference, and this evaporation that causes cooling effect. So, that I think everybody knows, because this evaporator, it serves a huge purpose in case of cooling system or refrigerating systems, where we know in case of refrigeration unit, for example, we can say we can cite this vapor compression refrigeration system. So, where we have seen that the different components of this vapor compression refrigeration circuit, where this evaporation, this compressor, then condenser, then expander. So, where this evaporator that basically placed beside this freezer box, where these products are generally to be refrigerated. I mean the foodstuffs what are supposed to be refrigerated here in this chamber, and that is basically placed just beside this evaporator. So, this evaporator, it always causes the cooling effect, and it plays a very dominant role in refrigeration systems, whereas in case of boiling, it does not cause any cooling effect. So, I think this is clear to all of you that what is the basic difference between this evaporation and coiling and evaporation and boiling, and now this mode of heat supply to evaporators. Now, this evaporation takes place that we know in evaporation chamber, where the dilute liquor or the solvent or the solutions consisting of this volatile solute and volatile solvent and non volatile solute, so that these evaporations where it will be taking place. So, now how this evaporation will be taking place and what are how this heat is generally supplied, because for the evaporation purpose. So, the different sources of energy, thermal energy that we generally employ for delivering the heat to the evaporation chamber, and by this the solution that will be evaporated, leaving behind a concentrated solution or leaving behind a concentrated thicker, this thick liquor. So, this generally we get. Now, what are the different ways by which you can supply this heat to the evaporation chamber? So, here this heat supplied includes the sensible heat for the solution to reach its boiling point and the latent heat of vaporization for the water evaporated. So, these are the different two heat or two energy items or the thermal energy items that we generally consider for the evaporation process to take place. So, one is sensible heat for the solution to reach its boiling point, and in the second phase or the second step that we can say the latent heat of vaporization that takes a very important part for the vaporization process to consider and this process to take place. So, now this heat is supplied to the liquid by the following three different ways. One is by radiation, and the second one the direct contact with hot gases, and the third one is contact with hot surfaces. So, these are the different ways by which the heat or the thermal energy can be supplied well to the evaporation chamber for the evaporation of a concentrated, for the evaporation of a dilute liquor. Vapor removal from evaporator. This is very important thing for an evaporation process to take place efficiently in evaporation chamber. So, we engineer, we always have to take care of it very carefully, because this vapor, if it is not removed properly, so then the evaporation process and the boiling process that can be stopped. Okay. So, it is necessary to remove the vapor from the evaporator for the continuous evaporation, otherwise the pressure above the solution soon becomes equal to the vapor pressure of water and boiling stoves. The vapor is generally removed from the evaporator in two ways. So, these are the two different ways by which this vapor can be removed: diffusion into an inert gas. So, this diffusion, so that if we consider into an inert gas and the directly in its pure states, if we can consider, so by which this vapor can be removed from this evaporator. Now, the classification of evaporators. So, let us consider these different classes of evaporators. How can these evaporator be classified into different categories? So, where these evaporators, it may be classified according to the different methods, the methods of heating. So, this is the basic core method by which this evaporator can be classified well, where this heating of evaporating liquid utilizing tubular heating surfaces, heating of evaporating liquid utilizing coils, jackets, double walls, flat plates, heating of evaporating liquid by direct fire, heating by solar radiation. So, these are the arrangements, these are the components or the accessories, okay. So, by which we can consider the classification of evaporators. So, this is the basic and this is the core way by which this evaporator can be classified. Now, there are many other ways by which this evaporator can be classified. So, here let us once more we can see that these are the different classes of this evaporator, where this natural circulation evaporator. Natural circulation evaporator means where there is no requirement of this pump or any external force. Basically, this evaporation where we do not require any external agency for this process, for this evaporation process to carry out. So, where this natural circulation evaporator means where this evaporator, that will be evaporation, evaporator will function naturally by circulating this fluid. Okay. So, here there is no required of attachment of any pump, or we do not require any external agency by which this fluid will be circulated. So, it can be categorized into long tube vertical falling film type evaporator, long tube vertical rising or climbing film type evaporator, forced circulation evaporator. So, in case of forced circulation evaporator, what is generally happen, where this circulation that will be done forcefully, where the pump that is generally employed to cause this circulation, and here this evaporation or the evaporator is classified as the forced circulation evaporator category, and under this category forced circulation with horizontal heating element, forced circulation evaporator with vertical heating element. Basically, this vertical heating element and horizontal heating element depends on the place or the alignment of the positions of this element, I mean the heat exchanger what we are using in evaporation in circuit. So, where how this is getting placed based on that, so that we can say this is horizontal heating element, vertical heating element, and these are basically categorized as forced circulation with horizontal and forced circulation with vertical heating elements. Agitated thin film evaporators, single effect evaporators and multiple effect evaporators. Actually, depending upon the effects, the evaporator that can be classified into different categories. So, let us have a look onto this. Depending upon the effects or the number of effects, how can the evaporator be classified into different categories? Here single effect. Single effect means the single evaporation unit what we generally consider for an evaporation process to take place, where the steam provides energy, that means the steam is supplied to the evaporation chest for providing energy, and the condensate that will be getting, and the superheated vapor that will be issued from the top of this evaporation chamber, and the concentrated liquor that we can generally get from the bottom or we can get from the down portion or the lower portion of this evaporation chamber that we can say. And here in that case this vapor is condensed and the concentrated liquor, that the product is withdrawn from the bottom of this evaporator, as I have already told that this bottom where from this product that can be withdrawn. And the double effect, the superheated vapor from the first effect evaporator is used to provide energy for a second evaporation unit. Basically, just in a thumb rule, if you can consider this double effect evaporator means it just considering or consists of two different evaporation unit, where the superheated vapor what is getting relieved from this top section of the evaporation unit, that will be used as the source of thermal energy for the next effect. So, the superheated vapor released from the first effect is used to provide energy or used to heat the fluid basically in the second evaporation unit. So, similarly, you can say in the same fashion we can define also the triple effect, the thermal energy of vapor from the second evaporation unit is used for heating in the third vaporization unit. This cascading of these effects can continue for many stages. Actually, this number of effects that we can use when our aim is to get a good amount, I mean a good yield, a good amount of products within a short span of time, or we can if we can optimize the process parameters, and if we can consider the process effectiveness and the cost effectiveness of an evaporation unit. So, in that case, as the number of effects increased, where the products that will be more and this cost it will be much more cost effective, cost economic. So, that we an engineer to take care of this cost effectiveness of this evaporation operation, and this number of effects as generally are recommended subject to this cost effectiveness and subject to this amount of products what we generally desire for a specific time or specific duration. Common type of uniters. So, let us consider these different types, common types of evaporator that are generally used in different chemical industries: open kettle or open pan type evaporator, horizontal tube natural circulation evaporator, vertical type natural circulation evaporator, long tube vertical type evaporator, falling film type evaporator, forced circulation type evaporator. But I have already defined what is forced circulation type evaporator and why it is called forced and why it is natural circulation. I mean why the natural circulation evaporator, what is the aim basically, agitated film evaporator and this open pan solar evaporator. So, these are the common types of evaporator that are generally found in different chemical industries and chemical process operations. Now, let us consider these long tube vertical type evaporations, where if we can just consider this operation or the working principle of this long tube vertical type evaporator. So, where just this is very much clearly noticeable that here this long tube vertical evaporation chamber, where the feed is introduced at the bottom and this condensate that we are getting from the lower portion of these heating elements or heating source basically, and the steam that is supplied, and this long tube vertical type evaporations. So, this long tube vertical type evaporation, this is widely used in different industries as compared to the other evaporator. This is cheapest per unit of capacity, and here this long tube vertical evaporator, it consists of one pass saline tube heat exchanger, and where this feed is introduced at the bottom and the steam is supplied from to the evaporation chamber from this upper section and the condensate that we are getting and this vapor. So, that the superheated vapor that will be released from the top and the concentrated liquor or the thick liquor that will be getting from the bottom of this. So, this is the way, and here the liquid that flows through the long tube and the tube length that varies from generally from 20 to 65 feet. And what is the advantage? Basically the advantage is to get the higher heat transfer rate here in case of this evaporation type or this evaporator type long tube vertical type evaporator. And here this long tube vertical type evaporator is used generally in paper and pulp industry for concentrating the liquor. I mean the black liquors what is generally used in paper and pulp industries. So, for the concentration for enhancement in concentrating this black liquor, this long tube vertical type evaporator is used in paper and pulp industries. Falling film evaporator. So, this is a very important pattern or important type of this evaporator, and this is also extensively used in different chemical process industries, and where this is very much clear that these products that we are getting from the bottom of this and where the feed that has been introduced at the top and this top where this solution if it is introduced and then it will be coming down along the tube length, and as it is falling down the solvent that will get vaporized and the concentration that will go on increasing, and the vapor and the liquid that are separated out where this vapor is that is going out and the liquid that means the concentrated liquid or concentrated liquor. So, that will be collected from the bottom, and this condensate I mean the steam as usual this steam that is supplied to the evaporation chamber, and this steam when it will be supplied. So, this evaporation process that will be taken place and this condensate that will be getting basically from the outlet of these heating elements. So, here this falling film evaporator this is also used in different industries, particularly for the concentration of different fruit juices. So, for concentrating this fruit juice the falling film evaporator that is used, and this falling film evaporator where evaporator one pump that is generally used for the recirculation of the liquid in this evaporation unit and to pass on. And for the concentration of this fruit juice generally this falling film evaporator is used. And one more application is very important application, so that we chemical engineer must remember that this falling film evaporator that is one of the problem solver of fouling or the scale deposition or the dart deposition or the dart accumulation, particularly it can very suitably take care of the fouling. So, this is a very problem, this is a fouling problem solver, and that is generally recommended for solving this fouling problem or the dart accumulation or the dart deposition along the surface of this evaporator. Now, this natural circulations. So, natural circulation is not suitable. Where this is not suitable? Actually, this natural circulation this is not suitable for the liquid to be handled, where if the liquid if it is highly viscous and if it is containing some suspended particulate matters, that means the solutions which will be considered for its conversion into concentrated liquor. So, it should not have that much of suspended particulate matter and it should not be viscous, and this for heat sensitive materials. So, this falling film evaporator that is also used, that means some organic compounds or pharmaceutical compounds what is heat sensitive or temperature sensitive, or it can be broken down and it can be converted into some other products what we generally not desire. So, in that case these heat sensing materials or heat sensing compounds what is supposed to be processed in an evaporation. So, in that case this falling film evaporator that can play an important role in handling this kind of temperature sensitive compounds. Effect of liquid properties on evaporation. So, these are the different important properties. So, that we must remember that what are the different properties that we must consider for the selection of a liquid or the liquid which is supposed to be evaporated for its concentrated liquor. So, this concentration and viscosity of liquid. So, concentration this is the property of this liquid this concentration if it goes on increasing, so then what will happen, the viscosity that will go as increasing also, and which in turn it will increase the boiling point of this liquid. Now, the solubility and crystal formation. So, this solubility, that is also important factor to be taken into consideration, and the crystal formations, because this crystal formation if it is desired, then it is okay. If it is crystal formation, this is not desired, in that case it can be deposited on the surface of this tube length, and there might be the I mean scaling or the fouling factor or the dirt decompositions, and definitely that will resist the heat transfer rate and it will decrease the overall heat transfer coefficient. Entrainment of drops and foaming. Foaming, this is also important factor. Temperature sensitivity of materials, this is very important thing, as I have already told you, there are many compounds, these pharmaceutical compounds and any other compounds what are temperature sensitive. I mean at high temperature it may be converted into some other products apart from the desired products, and this is not not desirable. So, in that case the evaporator should be recommended in such a fashion, so where it can consider this kind of materials what will be converted on high temperature to some other products apart from the desired one. Corrosion, this is also very important, and that can also cause the fouling or the dirt accumulation or the dirt depositions. Method of feeding of evaporators. So, these are the different kinds of feeding methods. Forward feed means where the thin liquid, this is fed to the first by means of a pump and flows to the remaining effects in the same direction. That means, just for example, if we can say there are basically the triple effect evaporator and the 3 different evaporation units. So, now the forward feed means the feed is to be necessarily introduced at the first one, and then with the help of this pump, okay. So, this is to be passed on to the next effects, I mean the second effects, then third effects. So, first, second and third. So, this is the direction of this moving the products of this evaporator. Now, the backward feed. So, just if we can apply your common sense. So, we can say that for backward feed, where this feed will be introduced at the last effect and then it will be going ahead this 3, 2, 1. So, this is the way or this is the direction by which it will be moved. Here this mixed feed, in the mixed feed operations where this thin liquid is fed at the intermediate and until it flows until it reaches its last effect, and after reaching a part of the concentrated liquor is reintroduced in the effect before the effect it was fed earlier. And parallel feed, in the parallel feed operations where if we can go for considering the same examples where this unit consisting of 3 different evaporator, where in every evaporator where we have to introduce this feed and the product or the concentrated liquor that will be getting from the bottom of this evaporator and it will be taken out from this individual effect, and no transfer of concentrated liquor is allowed to the next effect. Basically, the product or the concentrated or thick liquor what you are getting from the bottom of this evaporator, that will not be allowed to pass on to the next effect. So, this is basically the parallel feed. Single effect evaporator, so that I have already discussed the single effect evaporator. This is the evaporation chamber where this feed is introduced and this saturated solution that is also fed here, and this condensate that will be getting from this bottom of this heating element, and concentrated liquor that will be obtained from the bottom of this evaporation chamber, and the superheated vapor that will be released from the top portion of this evaporator. Double effect evaporator, basically the same fashions where we are using here the 2 different evaporation units, and where from this superheated vapor what is getting released from the top portion of this evaporation unit, that will be allowed to pass on to the next one as the source of thermal energy. Basically, it will be provided to the next effect as the source of energy. So, this superheated vapor it will be passed on to the second one, and the partially concentrated liquor what you are getting from the bottom of this first evaporation unit. So, that will be also passed on to the next effects or next evaporation unit for its further processing. Triple effect evaporator, this is also the same thing where these 3 different evaporators are there, and from the first to second, second to third, basically the superheated vapor and the partially concentrated liquor that we are getting as the components in the exit products, that will be allowed to pass on to the next effects. So, this is basically the triple effect evaporator. So, now here let us go for an example to cite here to better understand this triple effect evaporator. So, where we can see that just we can consider this just have a look onto these operations. Just with the help of this animation we can better understand what is the function of this evaporation that goes on in triple effect evaporator. So, definitely everybody can understand this is a forward feed triple effect evaporator, where this brine solution that is getting introduced at the intermediate of this evaporation chest, and the product that is passed on to the second one, and the product what you are getting from the second one, that is also passed on to the third one, and the superheated vapor what is getting released from the top portion or the upper section of this evaporator unit, that will be allowed to pass on to the second one as the source of energy, and from the second one it will be also again to pass on to the third one for providing this thermal energy. Where performance evaluating factors. So, this is a very important thing because whenever we will be going for designing and developing one evaporator, we need to know that what are the different factors that influences the performance of an evaporator. So, these are the different factors, so by which you can consider that the evaluation of a performance. So, these are the different things, this capacity, steam economy, and the steam consumptions. So, these are the three different parameters that you can consider here for the evaluation of a evaporator. So, in order to evaluate the performance of an evaporator, these are the three things. So, capacity, this capacity is nothing but the number of kilograms of solvent vaporized per hour. In case of economy, what we can say. So, this number of kilograms of solvent evaporated or vaporized per number of kilograms of steam fed into the evaporator per kg of steam used. That means, per kg of steam used, number of kilograms of solvent vaporized. So, that is basically giving you the economy, and this is observed that for a single effect evaporator this is less than 1. The steam consumption, this is nothing but a ratio of capacity to the economy of an evaporator. So, we can evaluate the performance of an evaporator by these three different parameters: steam economy, then steam capacity, and steam consumptions. Boiling point elevations. So, this boiling point elevation, this is nothing but the vapor pressure of an aqueous solution, this is less than that of water at same temperature. So, as a result the boiling point of the solution will be higher than that of the water. So, this increase in boiling point over that of water is known as boiling point elevation, and vapor pressure lowering. So, here this boiling point of the aqueous solution, that will be more than that of water. So, whereas we can say the vapor pressure lowering means the vapor pressure that will be less than that of water. So, here this BP, that is also very important thing to be known. Now, how to determine this? Basically the During plot that we use to predict this boiling point elevation for a strong solutions, where we have observed that this boiling point, this states that the boiling point of a given solution is a linear function of the boiling point of a pure water at the same pressure. So, this linear function of this boiling point of pure water at the same pressure, that means at same pressure boiling point of water, pure water, and boiling point of the aqueous solution. And if we can consider and if we can plot it, so then the boiling point of this aqueous solution versus boiling point of water, in that case at different concentration will be getting the straight lines, and where from we can predict that the boiling point elevations, and this is the During plot. Just have a look onto this, where at different concentrations the aqueous solutions, its boiling point that has been plotted here, and this is the representations. And overall heat transfer coefficient, this is one of the important factor to be considered here for the design of this evaporator, where this overall heat transfer coefficient, this equation that we generally use for calculating Q equals to UA delta T. This U is the overall heat transfer coefficient, watt per meter square Kelvin, and here this overall heat transfer coefficient, we can see the different types of evaporator where this overall heat transfer coefficient will be different. So, for long tube, vertical, agitated film type, and this falling film evaporator. So, these are the different. So, we can have some idea about the overall heat transfer coefficient for different evaporators, and these are the different factors that influencing the steam capacity and economy. So, we have already defined the steam capacity and the steam economy. So, now for single effect and multiple effect, the steam capacity, how this is getting influenced by the different parameters. So, these are given here, this temperature of the feed, boiling point elevation, liquid head, and the overall heat transfer coefficient, and for steam economy, number of effects, temperature of the feed. Mechanical design of evaporator. So, mechanical design of evaporator consists of many parameters, many things, many ways that we can consider, but these are the very hardcore and very important points that we need to consider. This maximum allowable working pressure, that means the pressure at which it can be allowed to work, and this evaporator, so that is to be designed in such a way that these can withstand this much of pressure, that means the pressure that can be tolerated by this evaporator. So, this pressure is to be designed or this pressure is to be calculated, and this is basically the maximum allowable working pressure at which this evaporator can function. And the second is operating temperature and pressure, that means the temperature and pressure at which it can be operated, that means the evaporation process can be operated. Thermal expansion, this is also important factor, and the design temperature and pressure, that means this design temperature and pressure, this is a little different from this operating temperature and pressure. Design temperature and pressure means whenever we are going to design and develop this evaporator, the temperature and pressure at which it can better function. So, that is also to be taken care of, and that we generally consider, and that are called as this mass enthalpy balance for single effect evaporator. So, let us have a look onto these mass enthalpy balance or this mass energy balance, combined mass and energy balance. So, first of all we have seen that this overall material balance, that we can say this product, F for feed, P for product, and V is the vapor, and the solute balance is nothing but the component balance basically that we are getting, and finally this energy balance based on this latent heat of vaporization and the enthalpy terms which are associated with this evaporation process to take place. So, that has been considered. So, this is the way by which we can go for making a mass enthalpy balance. So, this is the illustration by which we can just understand how to calculate this overall heat transfer coefficient, heat transfer area, and how the consideration of different pressures and the amounts of this liquid water getting fed into this evaporation chamber. So, this is example by which you can understand this is a single effect evaporator. What has been schematically presented, that this feed 15,000 kg per hour, this is the rate at which this feed is introduced here, and the superheated vapor that is getting relieved from the top portion of this evaporator, heating steam, and the product its concentration is 60%, that will be obtained from the bottom of this evaporator, and this is the way just we have made a material balance of this caustic soda, and then the heating, I mean the enthalpy, sometimes we require this enthalpy value, we use this steam table for this enthalpy to know, and here finally the steam economy that you have got, this steam economy, this 0.8535 that I have already discussed, this steam economy that always should be less than 1 for single effect evaporator, and this rate of heat transfer that you have got this 7121 kilowatt by this principle, this Q equals to mCpt, where this mCpt that better be replaced by this H. So, this mass and enthalpy, so that we can consider for calculating the heat transfer rate. And logarithmic temperature, mean temperature difference, this is the LMTD. So, this is basically consisting of 3 different temperatures to calculate this LMTD, and by which we have got here this 80.27 degrees centigrade, and the heat transfer area that we are getting from this equation, this Q equals to UA delta T LMTD. And now the question is why you should consider this convective heat transfer in case of this calculation, because the other heat transfer mode that also can take part, but that are negligible as compared to the convective heat transfer. So, that is why the governing equation concerned with this convective heat transfer we are considering for the calculation of this. Now, the application area, so these are the different application area where you can get get the application of evaporator, we can get this milk, sugar, salt, hard candies, juice, these are the different products that we can get on evaporation operations. And this evaporation operation, this is also used in wastewater treatment, I mean the desalination of water, where this evaporator that are used in drying operation, in crystallization, in product concentration, volume reduction, solvent recovery. So, it finds use application, extensive application in different chemical process industries. Now, this is very important thing for an engineer, that what are the different criteria, what are the different important points that we need to consider an evaporator that should meet to be selected for its specific application in the chemical industries. So, let us have a look onto the selection criteria of evaporators. So, where the different points are there, where this viscosity, this feed condition, and where this viscosity, the high viscosity, medium viscosity, low viscosity, these are the 3 different viscosities are there, these ranges are given, and scaling or the dart decomposition or the dart accumulation. So, this is also important factor to be considered, crystal producing and solids in suspension, and one more thing is suitable for heat sensitive materials or not. So, considering these major parameters, we can consider here the selection or recommendation of an evaporator for its specific applications. So, these are the different types of evaporator, and considering these here we can recommend that this evaporator can better be recommended for its application in this industry. So, these are the different criteria what you can consider. Now, these are the reference books that we have used to develop this course, that we have basically adopted to prepare these course modules. And thank you very much, and I hope it will be productive to all my students and the research audience. Thank you very much.